The last thing we have to talk about in this packet is transformations, and I know a lot of you are very comfortable with transformations when you have my poster right in front of you that has the different colors of when you move up and when you move down and left and right, but you're not going to have that on the test. You're not going to have me on the test. You're not going to have that poster on the test. So you need to be fully confident and comfortable with transformations when given a function or a graph. Remember that left and right, if you're moving left and right, that's going to change your x value. That's going to directly affect your x. Up and down is going to affect your y. A stretch or compress is only going to be talking about parabolas or quadratics only, and that changes your a value. So remember, you have your quadratic function, you have y equals x squared plus 2x plus 7, and it's going to affect that 1, which is your a value. We're going to go through examples of linear, quadratic, and exponential functions, looking at the different types of transformations so that you can see how transformations can be applied to any function. Alright, so starting with linear. So if we want to shift it down, you're going to notice that for a linear function you can only shift it up and down, because moving it left and right is the same thing as moving it up and down because it has a constant slope. Because you have that constant slope, no matter what you do, no matter what transformation, it would either move it down at the same time it's moving it to the right or up and left. So only worry about the up and down. If you're moving down 5 units, all of your shifts are going to directly impact your y-intercept. So if your y-intercept is -4, -4 minus 5 is -9. So your new function is going to be y equals 3x minus 9. So all you're doing is, if it's down, you're going to subtract. If it's up, you're going to add. Very intuitive. If you're shifting up 3 units, you're going to shift this 2 up 3. So 2 plus 3 is 5. Your new function would be x plus 5. So 2 plus 3. Last, shifting down 4 units, you're going to take this 4 and you're going to do 4 minus 4, which is 0. So if you shift this down 4 units, you're going to get y equals -3x. So once again, for linear functions, we're only going to be talking about vertical shifts or shifting up and down, and that's going to directly impact your y-intercept. Okay, let's talk about quadratics. When you think about quadratics, this is what we learned about transformations for the first time. And we talked about how if it's inside the parentheses, it's going to be left and right, and it's also opposite of what you think. So remember that that plus sign is the t in left. So if you have a plus, it moves to the left. If you have a minus, it's going to move to the right. So if I want to shift this left 3 units, I have to directly impact my x value, so I have to put it in parentheses. So left 3 units would be plus 3. Remember, left is plus, so my new function would be y equals x plus 3 squared. Alright, number 31, if I want to shift down 3 units, I'm now going to be affecting my y-intercept, which is my constant. I'm going to subtract 3. So up and down is very intuitive. To move up, you add. To move down, you subtract. When I subtract 4 minus 3, I get 1. So everything stays the same. So x plus 3 squared plus 1. 4 minus 3 is 1. This one wants to do a vertical compression. So a vertical compression, vertical is this way. It wants to make it fatter. So if I have my rubber band, like I showed you in class, here's my rubber band, right? I don't know if you can see that. But I have my rubber band. If I vertically compress it, it gets fatter. But when I vertically stretch it, it gets skinnier. So a vertical compression makes something fatter. Fractions are fat. So when you think fat, you think fractions. So y equals, because it's a factor of 2, it's going to be 1/2 times x squared minus 4. So that vertical compression of 2 means fraction of 2, which would be 1/2. That's the hardest type of transformation, and if they do ask you that, I would be surprised, but it's definitely something you need to know. You definitely need to know about transformations because it is a standard that is prioritized not only in Fulton County, but in Georgia in general, because it's something you're going to need for geometry and algebra 2. The last type of function that we looked at was exponential functions, and we're going to do the same exact thing. First, we're going to shift this up 2 units. When we are talking up and down, we're talking about our number after the exponential term. We don't have anything after the exponential term, so you can imagine there's a plus 0 right here. To move it up 2, I'm going to add 2 to that 0, so my new function would be 2 to the power of x plus 2. Up and down, so when you're moving up and down, you're always changing the constant. Always. So when you're moving up and down, you're looking for your constant. I didn't have a constant here. 2 is not a constant because 2 has an exponent. My constant would have been 0. That's why I added 2 to 0. Shift to the right 4 units. So remember, left and right, you're directly impacting your x. Your x can be an exponent. So if I'm moving to the right, that means I'm subtracting. Subtracting 4 from this 6. 6 minus 4 is 2. So this would be y is 2 to the power of x plus 2 minus 1. Again, I'm subtracting because I'm moving to the right. So left equals add. Subtract is for right. So you should have these types of notes on your paper. Just because I say them, you should be writing them down. If I don't write it, you can still write it down. These are your notes. This is your personal study guide for the Georgia milestone. Shift down 3 units. Again, when we're going up and down, we're looking at our constant, so I'm going to directly impact this constant right here. 2 is a coefficient, 3 is a base number. This 2 is going to be your constant. It doesn't have a variable, it doesn't have an exponent. So down 3, I'd subtract 3. My new function would be 2 times 3 to the power of x minus 1. 2 minus 3 is negative 1. Okay, so down here they give us 3 different types of functions, and they would like for us to graph them and then graph them with the shift. So I'm going to do my first graphs in black and then switch to blue to show the shift. Alright, so I'm going to graph y equals 1/2 x minus 4. It's a linear function. You could use your table, or you could graph this linear function. I'm going to start at -4, so down 1, 2, 3, 4. Then I'm going to rise 1, run 2, so rise 1, run 2. All the way to the edges of my graph, and then go backwards. And then I'm going to connect here with a straight line. Okay, so now that I have graphed this, they want me to shift up 3 units. When you shift up, that directly affects your constant. So I'm going to add 3 to -4. My new function would be y equals 1/2 x minus 1. So I'm going to graph this new function in blue. So 1/2 x minus 1. I'm going to start at -1 right here. Do the same thing. I'm going to go up 1 over 2. Up 1 over 2. To go backwards, down 1, back 2. I know it's been a minute since we talked about graphing, but it's definitely something to keep in mind. Now, you can see with a linear function, these 2 lines are parallel. This shift moved it up 3 units, and it just kept the same slope. Nothing about the slope changed because all I did was move it straight up 3. Alright, moving on to my quadratic. The first function they want me to graph is x squared. X squared is the easiest for me to graph, but I'm going to go ahead and graph it using my table. So y equals, clear it out, x squared, second table. And we're going to graph from -3, 9. Let's see, zoom a little bit out for you. Okay, so -3, 1, 2, 3, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have -2, 4, so back to up 4. negative 1, 1 is right here. Then 1, 1, 0, 0, which we already plotted. 1, 1, 2, 4, and then 3, 9 right here. So this is my original function of y equals x squared. Now they want me to move to the left, which means add, and up, which means add. So left is going to directly impact my x, so I need to put it in parentheses. I'm going to write it in blue and draw it in blue. So I have y equals parenthesis x plus 4 squared plus 2. So I move to the left 4 and up 2. Left means plus, up means plus. Make sure you just put them in the right places. So now I can do the same thing. I'm going to graph it using my table. I have x plus 4 squared plus 2. Look at my table. Find smaller numbers that I can graph. Alright, negative 6, 6. I'll put this right here. So negative 6, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right there. Negative 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. Right here. Negative 4, 2. 1, 2, 3, 4. Up 2. Here. Negative 3, 3. 1, 2, 3. 1, 2, 3. And then negative 2, 6. So negative 1, 2, 3, 4, 5, 6. So now I'm going to connect these points. Perfect. And the easiest way to compare transformations for a quadratic function is to look at the vertex. So my vertex for my original function was at 0, 0. They wanted me to move left 4 and up 2. So if I move left 4, 1, 2, 3, 4, and up 2, you can see that's where my new vertex is. I know that I plotted these correctly. I know that that's my transformation. So it's very easy, and the best way to do this is to compare your vertices of quadratic functions. Last but not least, we are going to graph this exponential function. So I'm going to graph y equals 3 to the power of x. I'm going to look at my table. And, okay. So it looks like my asymptote is at 0 because these numbers just keep getting smaller and smaller and smaller. That e to the negative, that just means itty bitty tiny numbers. E means itsy bitsy. So my asymptote is going to be at 0, so I know it's going to level off right there at the x-axis. I'm going to plot these points. I have 0 over 0 up 1. I have over 1 up 3. Over 2 up 9. And it levels off at 0. So I know it's going to look something like that. Now all I'm going to do is shift this down 2 units. Down means subtract, and I'm also going to be subtracting from my missing constant. If you don't have a constant, you know that it's 0. 0 minus 2 is negative 2. So my new equation in blue is going to be y equals 3 to the power of x minus 2. Notice that the minus 2 is not up in the exponent with the x. That would be if I was moving to the right 2. If you're moving to the right, you directly impact your x. But when you're moving to the left, you also directly impact your x. When you're moving up and down, you impact your constant. So now I'm going to go back to my calculator. I'm going to modify this to be 3 to the power of x minus 2. Look at my table. And this time, my asymptote is very clearly at negative 2. I have negative 2 repeated over and over and over. So I have an asymptote at negative 2, and then I'm going to plot some other points. I have 0, negative 1, 1, 1, 2, 7, 2, 3, 4, 5, 6, 7. Oh, I mentioned that in this blue color. So I level off here at -2, and then when I connect these points, it looks something like that. So you can see that vertical shift downward of 2. Good luck, and I will see you next class.